Now that we know the basic structure of an atom, we can start to dive into how chemical reactions happen, right? And again, chemical reactions are important because chemical reactions is what life is. Everything that's happening in our bodies and our cells that maintain those qualities of being a living organism is because of chemical reactions, right? And a chemical reaction is really just atoms making or breaking or rearranging bonds. Okay, so atoms can connect together. We call those when atoms are connected together, we call it a chemical bond. And chemical reactions are what make, break, or rearrange chemical bonds. And the key piece of this is that, remember those electrons that are orbiting around the nucleus of an atom? Those electrons are what drive chemical bonds, okay? Especially or specifically the electrons in the outermost shell of an atom. Okay, and we'll dive into what that looks like. But we're going to cover here two main types of bonds, ionic and covalent bonds. The electrons of atoms can interact in a couple different ways. They can either be transferred from one atom to another. One atom can give up its electrons and another atom accepts those electrons. Or they can share electrons. Electrons can spend time around both atoms, okay? And it's this either sharing or transfer of electrons, giving up or receiving of electrons. That's the basis of chemical bonds, okay? And so when electrons are shared, that is what we call a covalent bond. When electrons of one atom are shared with the electrons of another atom, that's a covalent bond. When one atom gives up an electron and another atom accepts that electron, that is what we call an ionic bond, because when one atom gives up an electron, it forms an ion, and when the other atom takes that electron, accepts that electron, it also becomes an ion, and they become ions of opposite charges. So covalent and ionic bonds, so those are two main types, but really you should know covalent is when their electrons are shared, ionic is when electrons are physically moved from one atom to another. So let's dive more into covalent bonds, right? So each atom has electrons that zoom around it, and they zoom approximately around, they move around that nucleus of the atom in what we call shells. Okay, this is a simplified version again, but it helps us to understand how these atoms interact with each other. So like here's hydrogen. Okay, so here's a nucleus of hydrogen right here, and then here's its electron shell. So hydrogen has an atomic number of 1, so it's 1 proton. It also has a mass of 1, so it doesn't have any neutrons. And in its neutral state, it has 1 electron. The shell that's closest to this nucleus can hold 2 electrons. Okay, so this hydrogen atom right here has space for another electron in it. This hydrogen atom over here also has only 1 electron and has space for another electron in it. Okay, so atoms will make bonds in order to fill up the shell of electrons that's on the closest to the outside of the atom. So hydrogen only has this first shell, okay, and this first shell can hold 2 electrons in it, maximum. So what hydrogen does, hydrogen can bond, make a covalent bond with another hydrogen atom where they each share both of these electrons. So here we go, so this electron will spend time around this atom, and it will spend time around this atom in this electron shell. Okay, and this electron will spend time around this atom and around that atom. Okay, so now it's as if they both have 2 electrons in this outermost shell. Okay, which makes it seem like they have a quote-unquote full shell. First shell of electrons can hold 2, and once that first shell is full, we then start to fill up the second and the third electron shells. Okay, so like if we look at oxygen. Here's an oxygen atom bonded to another oxygen atom. So oxygen has a total of 8 electrons. Okay, so the first 2 electrons are going to go here in this innermost shell, and then the next 6 will fill out the outermost shell. Okay, so this second shell can hold up to 8. So if this shell has less than 8 electrons, that atom is not stable. It's reactive. It will make bonds with other atoms in order to fill up that outermost shell. Okay? So oxygen, again, will make a covalent bond with another oxygen atom or another, maybe a carbon or a hydrogen atom to reach that 8 electrons. Okay, so oxygen can make up to 2 covalent bonds with other atoms in order to fill up that outer electron shell. Okay, so this oxygen atom will share these 2 electrons with this one, and this oxygen atom will share these 2 electrons with this atom. Okay, so these electrons will spend time moving around the electron shells of both atoms, and that's what physically holds these 2 atoms together. That's what creates a chemical bond that holds those 2 atoms together to create a molecule. So atoms will react, will make bonds with other atoms in order to fill up that outermost shell. So if an atom has its second or third shell with electrons in it, it will seek to fill up that shell to a total of 8 electrons. And we draw these out with little dashes, right? So here's again this hydrogen, when we only have one pair of electrons that are shared, that's a single bond, okay? And so it's going to be one line between the 2. In an oxygen atom we were just looking at, we have 2 pairs of electrons that are being shared between both atoms, and so we call that a double bond. And so here's one oxygen atom, bond, bond, 1 pair of electrons, 2 pairs of electrons, bond into another oxygen atom. Sometimes we'll see triple bonds, and that's when we have a total of 6 electrons or 3 pairs of electrons that are shared, and then like in nitrogen, so nitrogen gas, that's most of our atmosphere is nitrogen gas. We have nitrogen sharing 3 pairs of electrons with a second nitrogen atom, and so we'll have 3 lines, 1, 2, 3, okay? And so that's what these lines mean. These lines represent shared electrons. And so when atoms bond together, they then create what we call molecules, okay? And these molecules are held together by covalent bonds, right? They can be the same or they can be different atoms, okay? So here we have nitrogen with 3 hydrogens to make ammonia. So we have nitrogen and hydrogen, 2 different types of elements. Or hydrogen sulfide, sulfur with 2 hydrogens, okay? So different elements bonded together. But they're still, we call this a molecule. So most of the atoms or elements that are important to life, hydrogen, oxygen, sulfur, nitrogen, and carbon, hydrogen can make 1 bond, oxygen can make up to 2 bonds, sulfur also 2, nitrogen 3, and carbon can make 4. So this is one of the reasons why carbon is the backbone of life, or is the most common element in living organisms, because it can make up to 4 other bonds. It can make up to 4 covalent bonds, which is huge, which means there's a lot of variety. There's a lot of different ways we can connect this together to other atoms, to other carbons, to other elements, to make a wide, huge variety of molecules. Okay, so this is why carbon is the basis of life on our planet, because it can make 4 bonds, which gives it a lot of versatility. So we'll often look at the structural formula or maybe the chemical formula. So this just tells us, the chemical formula tells us how many of each type of atom are in that molecule. So in water we have 2 hydrogens and an oxygen. The structural formula shows us how they're arranged. Okay, so we see that the oxygen is bonded to hydrogen on either side. Sometimes we'll look at these ball and stick models or a space filling model, and these are just more representations to help us see how would that molecule look, and what would the angle of those bonds be, and how would it look more accurately than necessarily the structural formula. Okay, but these are all representing the same thing, water. Okay, so covalent is when electrons are shared. They spend time around 2 atoms. Some atoms, though, will readily give up or accept electrons. Okay, so some atoms will form what we call ions by getting rid of or accepting electrons from another atom. Because electrons have a negative charge, when an atom loses an electron, it becomes an ion. Okay, so when it becomes a positively charged ion. So losing an electron, if an atom loses an electron, that then will form a positively charged ion. Okay, and again, ion is just an atom with a charge to it. And that charge is due to the different number of protons versus electrons. So if one atom gives up an electron, it loses an electron, that electron has to go somewhere. It doesn't just zoom off into space. The electron has to be transferred to a second atom. Okay, so the second atom will accept that electron that one atom gave up. And when that atom gains an electron, it becomes negatively charged. Okay, so losing an electron, you become positively charged. Gaining an electron, you become negatively charged. And opposite charges are attracted to each other. When we have 2 ions of opposite charges, that are near each other, they are going to be held together by what we call an ionic bond. And that's just an electrostatic attraction between those two atoms, right? So this is how salt is formed. So sodium has in its third outermost shell, in sodium, it only has 1 electron, okay? It wants 8, so it needs 7 other electrons to fill up that outermost shell, right? Chlorine, on the other hand, has 7 electrons in its outermost shell. It only needs 1. Sounds like a pretty good deal here. Sodium, so what happens is that sodium transfers this 1 electron to chlorine. So sodium gives up this electron to chlorine. So sodium then becomes positively charged when it gives up this electron. Chlorine, when it accepts this electron, becomes negatively charged. Okay? And what happens once sodium gives up this electron, it's like this electron shell that was here, it just kind of disappears. And that exposes now this second shell, which already has 8 electrons. So sodium is now happy, basically. It has that octet, has that 8 electrons in its outermost shell. But sodium then becomes positive. Chlorine, which accepts this electron from sodium, becomes negative. And positive and negative are attracted to each other, and that creates an ionic bond that's held together. So again, we have our covalent bond, we have an ionic bond, and really all that's happening is the interaction of the outermost electrons on an atom. If they're being shared, it's a covalent bond. If those electrons are moving from one atom to another, it's an ionic bond.